read. What's it about? Selling sweatshirts. Yep, that's probably all you got the first time through. Okay, let's pick out what's important. 20 each. 300 students. Buy one.
Every $5 increment. 30 less. Want one. What price? Maximum. What is the profit?
Why is this called profit problems? Because we're selling stuff, making money off of it. How many of you are taking economics next year? So if you take economics, we'll talk about this in terms of economics and what does it mean. There's about 4 hands that went up. As long as it fits into your schedule. Tasha, don't bother arguing with him. Just don't. It's not worth it. Just like when we did dimension, the first one, you're going to be like, what? And then you're going to see the second one is going to look so much like the first one. And then the third one will look like the second, which looks like the first. I'm going to start with an equation, profit equals. And in general, when we are calculating profit, we take the number of items sold times the price. Now, when you get into economics, you'll realize that's not actually called profit. It's called revenue, because you would have had to pay for the sweatshirt, so you'd have to say, we're not getting into that. We're just doing general amount of money earned. So this is always going to be a number of objects. This is always going to be a dollar amount. So the first amount that we had sold was 300, and how much were they a piece? 20. So I'm putting those at the beginning of each of those binomials. Now what's happening is they're going to start changing the price, and they want to know, because the price changed, what's going to happen. The problem is we don't know exactly how they changed the price. All we know that it was $5 increments. Did the price go up or did the price go down, and how do you know from the question? That's a good way of thinking of it, but there's a keyword that's telling you the price is going up. Increment implies that you're increasing. So at $30 or $25, a certain amount of people bought it. At $20 or $40, a certain amount. At $50, exactly. So what I'm going to do is have X represent the number of increments. We talked about with number how you have to define the variable, so this is a really key piece of the question. That's defining the variable that I'm about to use. We didn't have to do that with height because it was given in the question. We did it with number by labeling the diagram, dimension by labeling the diagram. We did it with number, now we're doing it with profit. You can't just introduce a variable in math without telling somebody what it represents. Because I upped the price, what happened to the number sold? It went down by 30 people, and I'm going to throw in an X in the back because it went down 30 every single time I upped the price. The back of this one is going to represent the increment, which would be 5x. Why 5? Because that's how much I raised it, was $5. So the way these are always going to work is the first numbers in each binomial is the original amounts, or what we call before the change. The second numbers in each brackets are always going to be after the change, or the new amounts. The x's will always go in the back. Now what I'm going to do is just get rid of the brackets. So I'm going to FOIL this out. This is just a binomial times binomial. So I'm going to start with first 300 times 2 or times 20, 6,000. The outside 300 times 5x. Times 5x, 1,500x. Inside negative 30x times 20, negative 600x. And last I have negative 30x times positive 5x. X squared. Are we okay so far what I've done? Now I'm just going to reorder it and simplify it. So I want that negative 150x squared to come first. Then I'm going to combine those two x's. If I have 1,500 minus 600. And then I have the constant of 6,000. What kind of equation is it? Quadratic. What did we do now at this stage in every single other max-min problem? Complete the square, state the vertex, answer the problem. These are difficult in the sense that the numbers are big, but it's money. We like big numbers when we're talking about money. If we didn't have big numbers, we would not be in business. These are always going to be calc questions. Okay, so height are always calc. These are always calc. The other two just depends on the numbers. Is there a coefficient in front of the x squared? So what do we do with it? Factored out of the first two terms. Why did that turn negative? Because we divided by the negative. And remember that 6,000, what do I do with him? Just push him off to the end. I don't divide him out because he's just out there on his own. No, because we didn't factor him out, so he just hangs out there. Number here, number here. How do I find the first number that goes into the brackets? Middle divided by 2 squared. How many times have we done that now? So negative 6 divided by 2 squared. How do I balance off plus 9? Except so I have my negative 150 in the front. I need a binomial squared. That sounded confirmed. Then I just simplify all this stuff up. I think that's what we had. Confirm. Vertex. The x value of the vertex is whatever we called x. In terms of these questions, it's going to be the number of increments. The y value is always going to be the max profit. So it means the most money we're going to make on these is $7,350 if we sell them all. Okay, let's answer the question. What did the question ask us? And what's the profit, and what else did it ask? What price is what it wants. The price is not 3. That's not what this represents. What does this represent? The number of times we increase the price by $5. What I do to find the price is just grab this binomial right here. It's already set up for you. The price we know is 20 plus 5x. We know x is how much? Substitute it in. The maximum price that we want to charge is $35. In terms of the economics, what it means if we charge more than that, there's going to be less number that buy. If we charge less than that, we're not going to make as much money, right? So it's a balance in economics is what do you charge versus how many people are going to buy it. The second thing it wants to know is what is the max profit? What's the most amount of money we could make? That's right from the vertex. And it is $7,350. The only thing that's different between numbers dimension is just setting up this quadratic. Once we have the quadratic, everything from here down is exactly the same every single question. We simplify, we complete the square, we get the vertex, we answer the question. Okay, keep this one beside you if you can, if you don't have a nice coily notebook. I'm going to start the next one on a new page, and we're going to do it step by step. You're going to see it's going to look almost exactly the same. Okay. Look at number 8. It's like a mini novel. This is why we read to read, because we're not going to panic, we're not going to stress out, we're just going to read it like it's in a book. What's it about? Canoes. That's probably all you got the first time through, maybe some of the numbers and what's happening. First sentence, what do we need to know? $500 each. In terms of the math, do we care what they're selling? No, economists care. That's why they do what we do and mathematicians do what we do. Second sentence. Next sentence. Increased revenue as well, increased selling price, same thing. And the last sentence? What's a synonym for largest amount? Maximum. It's just a max-min problem. Okay, keep this one right beside you because we're going to do exactly the same thing. First thing we have to do is define the variable x we're about to use. X is, well, it doesn't use the word increments in this question. What's the similar word that it uses? Not revenue. You're looking for a word that means change. Increase, number of increases.
Wait a minute, did you say increasing number of increases?
No, I said increase.
No. Oh, I thought, because I thought you said something else because you were going to remind me of a thing. Kind of a fun thing that we do at my place. I was like, yay.
Okay, we always start with P, which stands for profit. Again, don't get caught up on the variable, but you need to have something on the left-hand side. You can't just have the expression without it being equal to something. And it's number sold times price. Original numbers go in the front, the changes go in the back. So before we changed anything, what was the original price? What was the original amount sold? $500. 60. Confirm. What's happening to the price? Plus 50x. Why do we have to put the x in there? Correct. And if we don't have an x, we're not going to have a quadratic. We won't be able to complete the square, and we'll cry. What's happening over here to the number? Do you see the similarity to the last question? Okay, FOIL it out. Does my 5 look like a 6 and you're confused? Nothing. Nothing, Julie? Nothing? Nothing. I'm not sure what number that was.
2000. I thought the second term was 3000. Yeah, and then the second term is 2. Yeah, that's right. The second term is just.
They had your back. They fixed it. It's all good. What do you want to do now? So peek of the last example. What did we do? Okay, what would you like to do, or what would you like me to write first?
Plus 1000.
What happens now with every single max min problem? Ooh, ooh, ooh. Okay, we want to fix this one, but we change this to 3000. Now we're good. Is there a coefficient in front of the x squared? What do we do with it?
And then we do x squared plus 1000x and then little space and then plus 30,000.
Oh, okay. I love how everything's a question.
Yeah, well, I'm all by myself here.
Uh-huh. They don't have your back at all. Just negative 5x?
And then you divide it by.
Has to be positive.
Well, half of that is.
Which is the same as 25 on 4, if you want to do it in fraction. How do we balance? Are we okay where these numbers are coming from? Oh, thank you. Confirm. Vertex. Answer the question. What does it want to know? Okay, where in this mess do I find information about price? Yeah, this is why I like to use the words first, because then it's really obvious which piece is the price. Okay, so price is going to equal 500 plus 50 times x. What's x? 2.5. Offer of 625. Show me your thumb on profit. Getting it, kind of getting it, not getting it. Good. The last one, how about with a friend? Give you 5 minutes or so.
No. Are you on pause?
I was.
You know, show up. Oh, I gotta write this down.
Plus 6,250.
Confirm.
Yeah. Yeah. Oh, we forgot to. Oh, yeah. I already did that. I did do that. I did the subtraction. I'm sorry.
6,250.
What does the question want to know?
Number of trees.
Okay, so where do we find information on number of trees? That's why I like to use the words, because then it's really clear in this step that we're dealing with this binomial. So number of trees. Grab the calendar. I have a suggestion.